Hi, so in today's video we are going to build something. As you remember from the last video, we have started to put the battery bank together, and then I promised you that we will do some electrical connections. And what all do we need to make electrical connections? Well, we need a lot of things. And here I have 1, 2, 3 boxes full of nice stuff. Let me show you what I have here. Okay, box number 1. This is an AC charger. I will take it out later and show you the details. Box number 2 is the battery grid-tied inverter. And box number 3, full of other nice things: sensors, breakers, cables, bus bars, etc, etc. So as a disclaimer, this is not an unboxing video, and none of these items I got from somebody for free or anything. This is all these components for Powerwall I had to buy, and we will just put it together, so it's no advertising for anybody. What I've been showing you is devices, components which I think is the best for making our project. Okay, let's check first what's in this nice box here. As you know, first of all we are going to finish the connections inside the battery compartment. And what we do not have there yet is bus bars. So I made bus bars from aluminium, which I had laying around. This is 25 millimeters times 2 millimeters, so it's a 50 square millimeter aluminium bar. And you can see I prepared 6 holes, and this will connect 6 cells together. So 3 in parallel and then serial. So this we will connect first. Then what we have? Some other bus bars, terminals, DC breakers. All I need here is components used at a DIN rail system. So here's the DIN rails. Then what we have more, we have AC breakers, more AC breakers, then cables, of course, another cable, cat 5 cable for our Modbus, more cables, crimps, screws, these are terminal blocks, 1 block for our DC and another block for AC. Yeah, screws, more and more. And then I have here together with a shunt, this is a power monitor. So this will put into the discharge cycle, so between battery and inverter, and it will tell us how much we have discharged, and we can see the capacity of our battery pack. And then we have jumper cables, etc, etc. So this is the content of our box. So let's move on a little bit further. To our other components. This one you might know from other videos on YouTube. This is a Sun 2000 GTL2 inverter, and the special on this inverter is that it can discharge from a battery. This is very rare for grid-tie solar inverters, and it comes with a limiter. So this is a CT for the limiter. This will be put into our main distribution box so that we do not export any of our stored energy to the grid. And its cable. And the last thing, this is one of our two chargers. This is the 30 amp charger, and actually this is a small vehicle charger, so very robust. You see, there's not even a switch on this. It is just plugged into the wall, and it will deliver the 48 volts. But this kind of chargers, they are actually customized for your battery pack. So in this case, for the lithium iron phosphate 16S. So it will put out the maximum voltage of 58.4 volts and 30 amps. I also have, for our build, we need two of these. This is the 30 amp, and there will be another one coming with 20 amps. But at the moment I only have one because I wanted to test and see the quality of this thing. Yeah, I think it will take roughly maybe 3 hours to put all this together, and I will show you at the place of the battery how all of this will be connected. Okay, so let's go and start building. Okay, let me show you quickly how the battery cabinet looks like now. From the last video you can you remember that we only had this part here behind this door, which I have reclaimed from some renovation, and I already closed up the walls here. But if I open this, you remember we have our battery cells here inside. Here on the app I already started to connect some of the cells just to see if all the holes and everything on my bus bars were the correct distance. So we will then continue the build and finish up the connections. I unfortunately did not get the BMS yet because, you know, due to the situation at the moment in the world of logistics, it takes quite long to get some stuff. So behind the glass door is the electronics compartment. Here we will build our system today, our electronics. The inverter will come here, chargers here, then the terminals with breakers in this place, and this place will be left for the controller, which we don't have yet because we did not build it yet. So that will be the last step. But nevertheless, after finishing this build, it will be, let's say, 90% complete. We can already test. We can make a test charge, test discharge, just by flipping on the breakers. And this is my plan. I just want to know how much capacity their battery cells still have. This is a very important question. Here inside the wall you can see a 1 inch 25mm conduit. And where does it go? By the side of the wall. Yeah, and you know the place, it is the main distribution box. Yeah. Inside there we have to make then also the final connections to make everything working. Yeah. Short way from here to here. That is what I told you, the plan. The battery needs to be as close as possible to the entry point of your grid. Then the AC-Powerwall will work its best. First step, finish up the battery. Take a bus bar, take screws and washers. connect 6 cells, 3 parallel, then the serial connection for the next 3. So I'm not going to bore you and let you look how I'm connecting this. So I will finish up and then we will see what is the final result. Okay, all the connections are done so far. What we are now interested in is what is the voltage between here. This is our battery minus, and here is our battery plus. All the cells have been kind of sitting at around 3.25, 3.26 volts. That's times 16. Let's see what is the voltage we get. You cannot see it, of course, but I will tell you. Okay, plus and minus. We have a peak voltage of 52.1. So 52.1, I looked up a discharge table, generic discharge table for lithium iron phosphate cells, and the pack as it sits here should sit around 80 to 90% state of charge, so quite high. What is not yet done, those of you who are familiar with battery builds, we don't have the leads for the BMS balancing cables yet, so there's no BMS yet. That's why I didn't put it. And later on, once we have the breaker, the main breaker, then we will connect also the 2 poles, plus and minus pole, to the breaker. Okay, that was it now, and the next step is on the other side. Here at the electronics compartment, we will place the inverter and the charger and the DIN rails to put the terminals and the breakers. This is the side of the electronics compartment, and the next we will check how the inverter will fit in this space, and next to the inverter will be the 2 chargers, from which we only have 1 at the moment. Yeah, let's take those 2 devices and put it into their place. Right, the first 2 DIN rails are set. On the up, this will be the DC terminal, and then for the DC breakers. Why did I put them on the extra rail, and why so far away? Because you know the DC cables are all thicker dimensions. They are kind of trickier to fiddle around, so that's why I've separated them. And on the down, the last DIN rail will be for AC. Far it. We are going to now put some breakers. Unfortunately, what I also did not get yet is the 100 amps DC main breaker for the battery. So I will instead use for the time the 63 amps, which was supposed to go to the inverter, but that one will be used at the moment for the battery main disconnect, and then another 32 amps I will just use it for inverter or for the charger, just for the test procedure to be able to shut it on and off. These are the terminals, the terminal blocks. There's 2 copper bus bars, so one will be plus, one is the minus. And on the AC side, it's one for the hot wire and the other one for the neutral. This is as well DIN, and just clicked onto the rail. Okay. just like that. So on the AC side we have another terminal block. Then we have two 1-pole breakers, just 10 amps. This is for each of the two chargers. And just a simple meter. With the meter I want to see how much the chargers actually have used. So this gives us a quite good picture of how much energy was pushed into the batteries overall. So you see on the AC side I'll just put everything on one rail because the cables are pretty thin, so we can just route them however we need it. These cables now, which are too long and kind of, you know, I don't need a plug. I don't need as well the Anderson plug on this side. We will now cut and then connect to the breaker and to the bus bar. Okay, we have cut and removed the outer silicone shell, and now we have the single wires of the AC cable connection from the charger, and we just connect one to the ground. One goes, the hot wire goes to the breaker. And the blue one is the neutral, and we put it on the upper rail here. The rail behind we will keep for the hot wire, so that nobody can incidentally touch it with the finger. Yeah, later on I will fix this cable somewhere, put it on the board, and so it will stay, it will be not loose. Right, now we do the same thing with the DC cable. Okay, what did I do now? I have connected the inverter. Just keep in mind all these cables are now extra long, and because it's still temporary, once I have all the breakers I have to set up everything really nicely. So the inverter on the breaker and the shunt for the monitor. So this is already final. The next I will do is connect the battery directly to the terminal. So we actually then have power available to the inverter already. Okay, I finished the work on the battery and electronics compartment. You see the final plus pole connected, minus connected, and we are going straight into the main breaker now. This is temporary main breaker. At 63 amps will be changed to 100 amps, and this goes into the terminal block, and from the terminal block here already for the inverter side the power meter with its shunt, and as you can see it already works. In the next step we have to do the connections through this conduit here into our main distribution box, and that is the next thing what we will do. See you in a bit from the other side of this wall. Okay, we are here now at the main distribution box, and let me show you here what we can do. I have flipped the main breaker, but we still need to watch this place. This is all still hot, it comes straight from the transformer. The only place I can put the DIN rail and my breakers is actually here on the upper part, but that's a good place anyway, because here is my hole for the cables, and the behind there, cannot see it, there is that conduit. I already put the cable from the limiter there, and you can see here the limiter I clipped onto this bus bar. That is the path to the main building, phase number 2, and the main building, phase number 2, is our owner's apartment. So the owner's apartment will be used every night. You know, we have air conditioning running and this kind of thing, so it's a good place to discharge energy during the night time. So now I will continue to put this cable will be for the chargers, AC, and this one is a return from the inverter, and the Cat 5 cable for the Modbus. And once this is installed, I will make the DIN rail there and put 2 breakers, and then make the final connections. One will be here on this breaker for the bleeding of the solar system power, and the other one is here then on this for the return from the inverter to feed into that phase from the inverter. Okay, let's do it and then see the result later. Okay, what have I done so far now? See here, all the cables are in. It's 4 cables, so the sensor from the inverter and the return line and the charger. This is the 2 breakers here. Right side is the inverter feed in, and left side the charger. And the blue, that's the Cat 5 cable, is going for the time here to my X835 smart meter. And when we have the controller, we will just connect 2 of those leads which are inside the Cat 5 cable here to the A and B Modbus output. Yeah, the last thing I have to do is connect the grounding here to the ground bar and the 2 cables here on the breakers. Okay, we finished also the part here on the down. Let me show you. So there at this point we bleed it off with 2 cables. That is the chargers, the power from the chargers, which will come from the solar system. And here on the middle one is where we will feed in. And that one, the yellow green, that's the grounding. Okay, so far so good. We can close up, and then now we can already check inside the electronics cabinet if everything is working. Let's go to the other side again. Okay, back at the electronics compartment, you see the 4 cables, wires coming from the other side. This one for the chargers, so we will connect the AC side here, and then the white one has to be connected to the inverter output. And for the Modbus, we just keep for the moment, and the limiter are already connected. It is connected to the inverter's internal limiter socket. Okay, let's do these connections, final connections, and then we are already soon finished for today. Okay guys, look at this. I finished all the connections. AC, DC, the meter. And I already switched on the inverter. It's working. Putting out already 60 watts. And the limiter is working. The small value there is showing how much it is putting out and limiting. And the charger. We should not run them both at the same time, doesn't make sense, but I'm just testing. Charger is running. It's already charging the battery. So I'm going to switch off the inverter, the DC from the inverter, then it will stop. Yeah, it will stay at 0 watts. We will keep it like this. This inverter is actually activated by the AC, so as long as you don't have AC, all this will stay dark. So you need the AC and the DC, if it's available, then it will start operating. So the plan is now to just let the battery pack charge to its maximum voltage, and then we will reset the monitor and make a discharge, a full discharge, to see how much capacity the battery packs have. Yeah, here you see I put the meter, kilowatt hours. Yeah, so the meter will show us how much kilowatts hours have been put into the battery until we are full lit. Yeah, we don't have the controller yet, but we still can manually operate. We can just switch on the circuit breakers as we need it, and we just need to monitor the voltages of the pack so that none of the cells are running out of the limit. Okay, so thank you very much for watching. This was quite a long day. It is now about 3 o'clock afternoon, and next time it's about testing and see how big the battery pack capacity really is. So thank you very much for watching today's episode. Please subscribe if you're interested in the further videos, and we already came very far. This will all look much better within the next few days or weeks. Whenever we got more of our components, we will then continue our build of our AC Powerwall. Thank you, see you next time.